All right. Looks like everybody's here. You guys get all your homework done? Just kidding. Okay, so any questions about any of the stuff that we did yesterday? This stuff, I warn you, this stuff at the beginning, you know, is kind of tedious and mundane. The real story starts in chapter 3. Okay? So, no questions? We're all good to go? By the way, you also don't have to worry about having your voice be in the video recording. We found out yesterday that this mic does not pick up your... So actually, I might maybe repeat or rephrase your questions or your comments just for the sake of the recording. So anyway. All right, well, if there's no questions, let's do the next example. Okay. So how about this? Z plus y, textual substitution, z comma y, replaced by 5 comma 6, equals by TS. Josh, can you help us out here? Oops. Just turn, oops. Oh, good question. What do you, yeah, is this a repeat? Yeah, what do you, okay, so what do you think it is, Josh?
It's parentheses 5 plus 6. 5 in parentheses.
Freeze.
Yeah, plus 6 in parentheses.
Okay.
No, group it all in parentheses.
Oh, you mean group the whole thing?
Yeah.
What? What?
I don't think you need to.
No, we don't need to do that. No, we don't. That's when we started.
Ah.
We did the same one with parentheses.
Okay. All right. Okay. But is everybody good now? Does everybody think that this is right?
Yeah.
Yes.
Wrong. Trick question. I caught you. Do you want to see why this is wrong?
Oh, the y is.
Huh?
No.
Huh?
It's not, I think the beginning has to be in parentheses.
Well, wait. What do you mean it has to be? This is the given problem. If we want to do, this is given. This is given. What's this? This is given. This is incorrect. Anybody see why?
Is it because we don't do anything with the z yet? We don't have to do
Well, how do we know what to do with it? Why? What's with the z? Yeah, you're right. The problem is with the z. Yeah, you're right at the. But
it's not grouped with the y, right?
how do you know?
Because textual substitution comes before it.
Now, now you got it. It's the precedence.
So the z is.
Look, it's the precedence. Let's take a look at the precedence. Here, okay, so what is this operator here? That's the plus, right? So where's the plus? The plus is at F, yeah? But what is this y with this textual substitution? Where's textual substitution? That's A. Ah. Okay.
It's called cheating.
No. That's not cheating. That's not cheating. Yeah. These are just the rules. Okay. We have the precedence rules. Okay. So now, actually.
Z plus parentheses 5.
Yeah. So now it's z plus parentheses. Now this is interesting.
Just
Y. Yeah.
Y.
Now, yeah. This is y, so what we have to do is y, and everywhere there's a z, we replace it by 5, and y, we replace it by 6. So this is everybody good?
Yeah.
And now, we're up, and then that's z plus 6. Okay, are we good? See? What, question? Still a question?
So why is it just with the y and not the z?
All right, okay, you remember, remember how precedence works. If you do 2 plus 3 times 4, the reason this multiply applies to the 3 and the 4 first is because this multiply has higher precedence than the plus, right? So you don't do this. This is not the same thing as 2 plus 3 times 4. Are you with me? Okay, so I mean, are you with me with this one? This is algebra, okay? So what we have here is we have the same kind of thing going on. We have two things that are next to each other. What we have next to each other is the plus and the textual substitution.
Oh, okay.
You see,
Like
and
C plus textual
substitution, right. And the reason that we know that is because this textual substitute, the reason we do it this way and we don't include the z is because textual substitution, like we learned last time, is at the highest level of precedence.
That makes sense.
Okay? Are we good?
Yeah.
Yeah, see? Now, let me just say, this was easy to, it was a good question. It's easy to understand the answer because we can all relate it to what we've known before and what was familiar. And let me tell you, when we get into these formal methods, if somebody comes in who doesn't know formal methods and comes in like in the middle of our class 2 months from now, they would be completely lost and they would think it was really, really hard. But every single step is as easy as this. I don't know why there is an innate, fear of symbolism and formal methods. People just they just think it's hard, but it's not. It's easy. It's as easy as what we just did, every step. Okay, anyway, I digress. All right, here, let's do some more examples. Okay, so let's do, next one we'll do, it's like, how about this? 35 textual substitution, x replace 7. Rochelle, what do you think? 35.
It would be the same, just parentheses.
Parentheses?
Yeah, so it's just
Yeah, that's right. That's 35. Okay, so everybody understands this kind of problems. This might happen occasionally. You'll do a textual substitution with the expression with the variable and it's not there, and so how about this? Y and textual substitution, x replace 7. So what would this be by textual substitution?
Y.
But
Just why?
not even parentheses,
Just be Y.
just y. Now is everybody clear on how that works? Okay. And how about this? Can you see this? Textual substitution, x replace 2. So now what would this be? This would be equals by textual substitution. What would this be? Parentheses 2, which would equal by rup 2. Yeah? Are we good? Okay, how about this? How about parentheses x times x plus y parentheses textual substitution x replace c plus y, like this. What do you think, Mason? Equals by.
So you would do parentheses and then parentheses C plus Y close parentheses times parentheses C plus Y again,
Good?
close parentheses plus Y close parentheses.
Yes. Good. And then which equals by. Can we remove some? I guess just the outer ones, huh? Okay? Sounds like you guys are getting it all right.
So how is it that textual substitution is like part of the problem in this? Because in like calculus, the substitution is like a separate faction of the problem. It's like just kind of off to the side. So like, what does it mean, or how is it that I don't quite get, like, I understand what we're doing perfectly fine, but I don't understand why.
Oh, that, yeah. I see, yeah. It's hard for me to explain now.
Okay.
Why? Because this is a tool that we're going to use in the proof process. And you just have to take it on faith right now.
Okay.
Yeah. Have faith, sister. Okay, so.
Hey, rephrase your questions.
Oh, right. The question was, yeah. Well, the question was, why are we doing this, basically, anyway. Yeah, it'll all come together. All of this will make more sense later on, and it seems, easy and trivial now, but you'll see later. Okay, and how about this one? How about x plus y, textual substitution, xy replace zw. Okay, so this equals, what do you think, Ben?
Would be, okay, so the first one's just an x, right?
Yeah, sorry, this is x, yeah. Okay,
Okay. So it'd be parentheses,
yeah.
and open parentheses z,
Open parentheses z,
close parentheses, plus open parentheses w, close parentheses, plus open parentheses w, close parentheses, close parentheses,
yes, good. And then equals by rough.
z plus w plus, you wouldn't do 2w, would you, or just w?
Oh, yeah, we're not going to do, a good question. We're not actually going to do very much algebra. We'll do a little bit, but we're more interested in the form of it without doing all the algebra stuff. So for your homework, don't make that 2w.
Okay.
Yeah, okay. Okay, so here's a similar one. Josh, we'll go back to you. How about x plus y, textual substitution, xy replaced by 2 times y, comma, x times z.
Do the exact same thing, but wherever there's a z.
Okay, so can you, do the exact same thing, but why don't you just tell me what to write down.
Parentheses,
Okay,
and put 2 times y in parentheses.
okay, 2 times y paren
Plus x times z in parentheses.
plus x times z
Plus x times z.
plus x times z, close parentheses, equals,
Get rid of all the parentheses.
yeah, okay. Get rid of all the parentheses, he says. X. Okay. Here's an interesting one. This is going to happen occasionally, and so check this one out. Kyle, is that right? Okay. So x plus 2 times y. Now check this out. X comma y replaced by y comma x. Let's do a TS and RUP.
You can do that?
We are now.
Alright, so we're gonna get y plus parentheses 2 times, wait, no.
maybe we should just do TS
There we
in
go.
one step.
Okay.
No,
so
that's
get
it.
parentheses, y parentheses,
Oh, do you want to
what's that?
do you want to just do TS?
Yeah, that'd be better,
Okay.
for now.
All right. Okay.
So we'll get open parentheses,
Right.
open parentheses, y, close parentheses, plus 2 times, open parentheses, x, close parentheses, close parentheses.
Yeah. Okay, so now we can, so say it again?
So you won't need any other parentheses.
Right. Yeah? Now this, look, this is interesting because what happens is we're replacing x with something, but we're making it y, but we're replacing y with something and we're making it x. And this happens simultaneously. Do you see what I mean? We're not doing one first and then doing the, you see what I mean? So that's simultaneously, right? And you know, if you can do it for 2, you can do it for 3. And as a matter of fact, all of these examples are ones that are from our text. So, you know, if it doesn't have the variable, then that's just it. And then the one we just did was this one. And here you got 3, you know, x, y, z, replace z, y, oh, sorry. Ooh, maybe we should have done this one on the board. X, y, z replaced by z, x, y, right? So does everybody see how that works? Are you with me? The x, let me see, x becomes the z, the y becomes the x, and the z becomes the y. Yeah? Are we good? Good deal. Now, I want to show you an example that's, I'm not sure if it's in the book or not, it might not be. But this is going to crop up. This kind of problem is going to crop up in the future. So let me just repeat that one, just for purposes of getting it down. X plus 2 times y, textual substitution. X, y replaced by yx. So this is equal ts. And so this will be y plus 2 times x. Now, but now watch this. It's going to happen that you have things not happen simultaneously. It might happen that way. All right? So what if you have this situation? We'll have the same expression here. X plus 2 times y. And now we're going to have x replaced by y, textual substitution, y replaced by x. Okay?
Just do the x replaced by y first.
Now that is a good question. Do you do the x replaced by y first, or do you do the y replaced by x first? And that was a really good question. And you're saying that you're suggesting that we do the x replaced by y first.
Yeah, seems intuitive.
Yeah, it seems intuitive, and not only is it intuitive, is that's the only way you can do it. Because is everybody clear on this?
Left to right, like reading.
I'm sorry?
It's left to right, like reading.
Oh, left to right, like reading. Yeah, yeah. But also, you see, how could you do? The thing of it is that
They're not connected.
yeah, I mean, you know, if you put the parentheses around here and you wanted to do y replacement, well, you got y's here, you have a y here, but then you have a y here in a textual substitution. I mean, it kind of like wouldn't make sense to have the print. Wait, sorry.
You can have parentheses around the
That's
2
good.
outside things.
But you can have parentheses.
Well, I mean, it wouldn't make sense to have the parentheses here.
Yeah.
I mean, you'd be doing a textual substitution inside of a textual substitution. Yeah, that's what I'm saying. Yeah. I think I might have said that incorrectly before. No. His point is, which is a correct point, is you can't do that. Yeah. That's why you have to do the textual substitution here first.
It's like taking a log of log.
Right.
Wouldn't make sense.
Yeah. Well, yeah. Right. Yeah.
Log's like the
Yeah.
So you do a textual substitution twice. You do it the first time and then.
That's exactly what you have to do. Okay, so Rochelle, since you said so, can you tell us our first TS and RUP? So can you tell us?
Be y plus 2 times y.
So this part would be y plus, everywhere there's net, yeah. Okay, so this would be y plus 2 times y. And then this textual substitution will be y replaced by x. And so now, Mason, what's the next TS and RUP?
It would be x plus 2 times x.
Yes. All right. And now I have a question for you. This is an easy one. Ben, are these the same? You had the hard one. Now, wait a minute. This is now wait a minute. My question is, our point here is that this and this are not the same. Yep.
Yep.
Why not?
Let me tell you. You see, top one has a Y.
Wait, they don't have lines.
No, I mean in the answer.
Okay, say that again. You say the top one. Oh, no. Yeah, because that's why and this is it. No, but I'm saying why. My question is why did it turn out that way, and when could they ever be the same?
Because of the it wasn't simultaneous.
Well, right.
In the specific case.
You could do it where like, it would be the same. Or there'd be like where you'd have to do the substitution twice and it would end up the same as if you're doing it simultaneously.
Yeah, I will leave that. I will leave that question with you. All right. That. I mean, can you formulate the situation in which they would be the same?
Like
What would have to happen in order for them to be? What would have to happen in order for them to be the same?
them not to replace each other.
You
Well.
do useless substitution at first. Like every Z becomes like a Y and there's no Z's. The only way I can see.
Well, think about it. Okay, now, now this next demonstration is similar to the issue that we ran into here, and unfortunately, our textbook does not emphasize this. We're going to call this a property of textual substitution, and I'm going to formulate a rule here that's actually not formulated explicitly in the book. So, a property of and let me do two examples. All right. What we're going to do here is, and actually what we're going to concentrate on is doing two things in a row here, right? So here's going to be our first example. So our first example is A plus B times C. And now what we're going to say here is we're going to say B replaced by X followed by X replaced by B. All right? So equals TS and RUP the first time. Whose turn is it? Josh, maybe? We're doing the first one now.
Just the first exercise.
Yeah, I mean, we have to do this in two steps, right? So we'll do just for the first textual substitution step.
A plus X in parentheses times by C
Okay, good. So A
plus X
plus X times C, close parentheses, here. And then we still have left X replaced by B, right?
Do you need those out of parentheses?
Do you need any of them?
Yeah, you need to add.
Okay, now, the good question. Do you need the outer parentheses is the question.
The question is, do you need the inner ones? Because you don't. I don't think.
No, you need them because you're multiplying that.
You don't need the inside one.
You need all of them.
Oh,
You know,
right.
Yeah. Yeah. Okay, so after this big conversation, does everybody agree that you do need all of them?
Yes.
Yes.
You need this one because this has to apply to the whole thing. Otherwise, this would only apply to the C. Yeah? See, this is, you got to be careful.
It's getting complicated.
Yeah, but but is everybody, you,
I'm just getting lazy.
yeah.
Yes. You need your right.
Okay, so equals TS and Kyle?
Parentheses A plus B, close parentheses, times C.
Good. Okay. And now let's do, I'm going to have to squeeze, well, no, I'll do it over here. Okay, so now, example, A plus B. Yeah. Now we're going to do A plus B times X. And we're going to do B replace X, X replace B. What do we do over here? A plus B times C, B replace X, X replace B. Now we're doing A plus B times X, B replace X, X replace B, equals. You're up.
Just gonna be parentheses, A plus X, X,
Yeah, replace. You say replace by.
replaced by B.
Yeah, X replaced by B. Good. Okay. Next. I hope all you people out here in video land are trying to do this. It's your turn. Actually, Mason will do this next one for us.
Okay, the parentheses A plus B close parentheses times B.
Okay, now let's make a few observations. See if we can formulate a general rule. What do we notice about what we started with here and what we ended with here? They are the same. Now, doesn't it make sense that if we start with something and everywhere there's a B, we replace it by X, and then after that, after we do that, everywhere there's an X, we replace it by B? Doesn't it stand to reason?
Unless we started with an A.
Is the rule something like you can simplify the two textual substitutions? Like combine them?
Well,
Because every B ends up becoming a B.
Could you cross them out?
yeah, it's like they cancel out.
But only if
Except
the
But-
variable isn't within the.
Only if the variable isn't there.
Yes, 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 yes. I think everybody sees it. Because why wasn't, the question is, why wasn't this equal to this? Because what happened was,
All B's and X's became B's.
Both B and X were in the original. Yeah.
yeah, well, just which one? I mean, it's true that both of them were in there, but which was the crucial one?
The second one was already there.
Second one.
Yeah,
Yeah, it's already there.
yeah, the X was already there. So yeah. So see, this X was already here, right? So when we did this X replace B, this turned this one into this B, right? Okay, now everybody understands this, and you can see why. You see why in this case this is not the same as this, but you see over here this is the same as this. Okay? So here's our rule. This is, and unfortunately, like I mentioned before, our book doesn't emphasize this rule at this point. So let's make it explicit here. Now, we're also going to introduce the occurs notation. This is called a proviso. You know what a proviso is? Provided that. You know, so if you say, well, provided that, da 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 da, so when you say, well, this is true provided that blah blah blah, then you're giving a proviso. Okay, so the proviso is the noun form of the word. All right? So, and here's the proviso. Here's how we're going to formulate the rule. If, now, this is going to look strange, but here's a symbol that we're going to encounter many times later. Does anybody know how to say this? It's a line with a ch.
Negated?
Yeah, not. The way you say this in English is not. All right? So we're going to say if not occurs, all right? If not occurs, and now what we're going to do is put single quote x, comma, single quote, capital E, comma. All right? If not occurs, quote, little x, quote, comma, quote, E, quote. Okay?
So if X is not an E.
Basically, that's what it is. Now, do you remember what we said the other day about our convention for uppercase, lowercase?
Yeah. Uppercase.
What is it?
X is lowercase expression, uppercase is
Variable expression.
Correct. Lowercase is variable, uppercase is expression. So if this and so what this means, this is the formal way of that we will write. If this variable x does not occur in this expression e, then can you tell me e with y replaced by x followed by x replaced by y equals, Ben, what would it equal?
E.
Exactly, E. Okay, and that is so important that we will say it again.
your first X.
It does the
It has a curly
kind of like
Q.
a reaction. What do they call that?
Y replaced by x, x.
It just looked like RX for a second.
Oh, are we good? Is this good the way it is now? Okay, and this is, we're going to refer to this later. Okay, so this is a quote, property of textual substitution. Property of textual substitution, quote. And when we say, so actually we're going to use this in our proof, in some proofs later on. We'll have to say, we'll say, oh, well, you know, y replace x, x replace y, provided that this doesn't occur here, we can say that this equals this, boom, boom, and we'll just use it in, you know, and so we have to understand why.
When there's two textual substitutions, do we ever like simplify both at the same time? Like,
Oh, that's a good, yeah, no, that's a really good question. Yeah, and here's,
Because that, like, something like that, it's easy enough to do in just like in one go.
you are right. And here's what's going to happen. Here's the way that's going to work. What happens is, as we get more and more familiar with how to do the steps, we are going to start omitting steps and doing more in our heads.
Good.
Unfortunately, some of our heads are different from other heads, and so I might insist at the beginning that you be, you know, that you put the stuff down, but just go with the flow. So at the beginning, I might insist that you put some steps. And sometimes, even though the steps are easy, they are crucial. They are the crucial idea behind the proof. And so I will advise you, no, in this kind of a proof where we're trying to prove this property, you need to put that step in because that's the crucial, even though you can do it in your head. Anyway, it's a good, it's not a hard and fast rule. It's, you know, because I've had some students whom I will not name, but who happens to be in the room behind the camera, who like to do stuff like that in his head. Okay, well, all right. So, are you guys thoroughly tired of textual substitution? So, take a big, brief little 5-second break here, and on to the next topic. Okay? So I think we've said all there is to be said about textual substitution. Now everybody knows how it works. Okay, so now next topic, inference rule. You ever heard of that?
No.
Good. We have one honest participant. Okay, so here comes what is an inference rule. So here's how it works. First, let me give you the shape of an inference rule. Inference rules, the main shape of an inference rule is a horizontal line. So inference rules have a horizontal line. With the premise or hypothesis above the line, with the premises, premise, P-R-E-M-I-S-E, with the premise or hypothesis above the line and the conclusion below the line. And the conclusion below the line. All right? Now, there's one more comment that we have to make before we proceed with examples. The premise is assumed to be true in all states. What's the state? Well, what's the state?
List of variables in there.
Oh.
Values.
Huh?
List of variables in there.
Yeah. Remember that? A state is the list of variables and their values, okay? So
Some expressions are true.
sometimes some expressions are right. But now the main thing about this inference rule is that the premise is assumed to be true in all. If this premise is true, and if you assume that it's true in all states, then the conclusion follows from that. So let's give a few examples. So here's an example. Two times x equals 10. Now we're going to do a little algebra. What do you think? It's just really higher math, right? Okay. This is an example of an inference rule. In other words, if you assume that 2 times x equals 10 is true in all states, what follows? It therefore follows that x equals 5. Okay? Here's another example. This is a word problem. Pepperdine students are bright.
Question rule.
Hey, we said assume true in all states. Oh, we have a Texan in the... Okay, so Pepperdine students are bright, and I am a Pepperdine student. Phew. Inference rule. This is a... Exactly. Oh, man, in and out. You're sitting in a dangerous place there. I'm not very good at that. You better. Yeah, okay. So, yeah, conclusion, I am bright. Okay? Now, does everybody see the idea here? Okay? So, let's do now we're going to do one that's a little more involved, a little more mathematical. And this is called inference rule. This is called inference rule substitution, and in the book it's equation 1.1. Or it's, yeah. So this is called substitution. And here is the inference rule. E, capital E. Inference rule. Now, what did we say? If it's uppercase, it's an expression, which means it could have a lot of what? Variables in it, constants, variables, parentheses, prefix. What's the definition of expression? The first one is? Variable constant. Second one? If
E is an
E is an expression, E is expression. Third. If circle is a
unary
unary prefix operator, and
E
is an expression, then circle is an expression, and then if
star
is a binary infix operator, and E and D, whatever letters, are what? Then
E star D
is an expression. Okay. So this has a bunch of parens and unary prefix and binary infix operators, parentheses, blah blah blah, all over the place, right?
Maybe.
Yeah, it could be. Okay, but just in general. All right. And if that's the case, do you believe this? E, you doubt?
Is that a V?
That's a V. Is it uppercase or lowercase?
Variables are other expressions.
I think
Variable.
it's supposed to be lowercase.
This is.
I think
It's not just supposed to be a lowercase. It is a lowercase. You.
Okay, yeah. I see that.
You see that?
You're saying that all the variables are expressions.
No. No. This is textual substitution.
Okay.
So what I'm saying is that if you assume that E is true in all cases, in all states, if E is true in all states, it therefore necessarily follows that expression with any of its variables replaced by any other expression is also true.
Yeah, what is that supposed to
If this is true in all states. Remember we said remember what's the state? List of variables and its values, right?
Yeah.
So if in fact this is true in all states, I claim, this inference rule substitution claims that expression with any of its variables replaced by any other expression is also true. Well, do you believe it?
With any other.
No, I'm claiming that this is in fact the reality. This is the way the universe works. You don't believe
There's
it?
got to be some
I
exception.
doubt it.
Oh, you doubters. Ye of little faith.
Do we have to assume that the F is also true?
No, this is any expression.
What if that's
This can be any expression at
a
all.
false
But that's
expression?
not
and
true
a
in
true
every state, is
expression?
it?
True and a false.
No. Boy, we do have some doubters here. Okay, let me give you an example. By the way, this example is not in the book, and I think hopefully this will make things clear. All right, first of all, let me come up with an expression that's true in all states. What is, if you multiply a positive times a positive, what do you get?
Positive,
And what happens if you multiply a negative times a negative?
positive,
And what happens if you multiply 0 times 0?
0.
You get 0. So tell me this. Is this true in all states?
No.
Yes.
X squared is greater than.
What about when X is 0?
Yeah.
Oh.
Yes.
Sorry. Is this true in all states?
Yes.
Doesn't matter. It's true in all states. Okay. Therefore, now, so what goes here?
Squared is greater than 0.
So,
Okay. X replaced by, give me any expression at all. Just some arbitrary thing like b plus 3, right?
B plus 3.
Thank you.
That's true in all states.
It sure
I
is.
have a counterexample.
Oh, you don't have a counterexample.
That's the original one.
Huh?
The original. That.
I'm
yeah,
sure there are
that
examples
thing.
that are true, but
No. Remember what we said Inference Rule said. If you assume that this is true in all states,
Yeah. Okay, that could be true, but then what? So I have an example for F that you could. put
okay, before you give me the counterexample, let me write this out. Let me write out what this means. The meaning here is this. The meaning is, if you assume that x greater than or equal to 0, that x squared is greater than or equal to 0 in all states, it follows that b plus 3 squared is greater than or equal to 0. I mean, yeah? And I don't think you can give me a, you want to try?
But the original problem. Say you had like E, or say the expression you have.
This has to be the same as this expression. And if you assume this is true in all states, then...
X plus 5.
Okay, hold on. Let me write this down. So you have a counterexample. Maybe. Okay, so give me
X plus 5 equals 10.
x plus 5 equals 10.
Okay, so.
Now, we're assuming this is true in all states, right? So what has to come down here is x plus 5 equals 10. Textual substitution what?
X replaced with 6. That's not true.
But then this isn't true in all states. Remember, the assumption is if this is true in all states, if you assume that this is true in all states,
Right.
so your original thing doesn't hold.
Oh, okay. So the original expression has to be
Has to
true.
hold.
Well, you may or may not know whether it is true in all states,
So the
but the
only
inference
rule-
rule says
The only rule
there's a...
states X equals 5.
Yeah, but you see, you're starting with... I understand what you're trying to do, but the point of it is that for an inference rule to work, this has to be assumed. You have to assume, if you assume this is true in all states, then this would be true. If then it would be true that x, and what is this? 6 plus 5 equals 10. It would be true that 6 plus 5 equals 10. If this were true in all states, but it's not. So therefore, it's not. So that invalidates the whole thing.
Oh.
You see what I mean?
So therefore
So you're
it's
just
not.
like inferring, and if it's wrong, then it's wrong.
Well, if you start with remember, go back to what we wrote on the board. Inference rules have a horizontal line with the premise or hypothesis above the lines and the conclusion below the line. And remember, the next sentence was, the premise is assumed to be true in all states.
So, but
That
we
was
must be
key.
careful that we
You must be careful, yes.
which premises we use.
Yes, yes, that is a good point. And actually, in this example, you know that this is
Yeah.
true in all states. Well, for real numbers, not for imaginary numbers. Yes.
What about x replaced by root x? In that example.
X squared greater than.
Oh, well, you're going to try to trip us up because the square root is plus or minus kind of thing?
Yeah. we'll make-
Well, yeah, we won't go there. You know, we need to have a rule that the cameraman does not participate, try to trip me up. Anyway,
No, that's fair.
you think that's fair? Should we vote him in?
I think that's
Okay.
It wouldn't be true, would it?
I'm sorry, say that
In
again?
that case, though, the premise wouldn't be true, would it?
Oh, correct. Yeah. So you make my point again.
So is there a premise that's actually always true?
His point is that it's always true if the premise is true.
Yes.
That's the point.
Yeah. These are really, I mean, these are, well, no, I wasn't going to say theoretical. I'm going to say these are really good, interesting questions, and it's kind of deep. I mean, all of this machinery that we're learning here, all this logic machinery that we're learning, has been developed over centuries and centuries. And and I will say that this book that we're using is a new system of logic that is, it's brand new. It's within my generation. I mean, it was invented during my lifetime. And so not very many people, not very many mathematicians who are schooled in the old mathematical way do things quite like we're going to do them. But all of this inference rule stuff is all part and parcel of all logic systems, whether they're new logic systems or old. Anyway, it's time to go. It's been fun. We'll see you again with your homework, right?
Yeah.
On Thursday. Okay?